You've probably seen an AI confidently invent a totally fake fact at some point, right? Or maybe it spectacularly refused to handle what seemed like a super simple request. Well, welcome to this explainer. Today, we're demystifying the pretty chaotic world of artificial intelligence. We're going to learn exactly how developers transform these unpredictable models into testable, reliable software systems. So if you've ever wondered how they make sure an AI isn't just making things up as it goes, you are absolutely in the right place. Let's move past all the hype and really understand the mechanics of AI quality.
Okay, so think about a perfectly curated AI demo. It feels like a flawless oil painting. It shows this ideal, single use case that's pretty much guaranteed to impress investors or go totally viral on social media. But the gritty reality of everyday user inputs, it's basically an unpredictable storm. Real users ask incredibly difficult, nuanced questions. They give unclear or even completely contradictory instructions. And some folks actively try to break the system with complex jailbreak attempts just to bypass safety filters. This messy, chaotic reality is exactly why rigorous structured testing is literally the only way an AI survives in the wild.
And that brings us to the concept of an eval. An eval is a systematic, repeatable testing process. It's the actual solution that proves a good AI isn't just, getting lucky on a good day. Instead, reliable performance is the result of engineered repeatability. See, when an application has a language model, an intricate prompt, all sorts of data connections, and a user interface, evals don't just test the model in isolation. They evaluate the behavior of the entire system, top to bottom, making absolutely sure all those gears are turning together seamlessly. Here is a quick look at our roadmap for today. Number 1, foundations of quality measurement. 2, criteria and evaluation methods. 3, security, sources, and code. 4, fairness and bias. And 5, monitoring and governance. Let's jump right into Section 1, foundations of AI quality measurement. Now, a truly robust test dataset essentially acts as the long-term memory of the development process. You really can't just test an AI with your favorite perfectly phrased questions. A professional dataset requires a very deliberate balance, so you absolutely need frequent standard cases to prove basic everyday usability. But you also desperately need difficult, ambiguous edge cases to push the model's logic. You've got to throw intentional curveballs, like, say, asking it to summarize a completely blank document, just to see if it fails gracefully or if it completely crashes. Plus, every single time a real user discovers a flaw out there, that exact flaw has to be translated into a brand new test case to make sure it never happens again. Moving right along to Section 2, criteria and evaluation methods. So we have to break quality down into observable criteria. It's just not enough to say an AI's answer sounds generally good. We have to ask super specific questions. Is it factually correct? Is it actually helpful to the user's specific goal? Is it safe? And does it follow the exact format we requested? The absolutely crucial thing to understand here is that there are constant trade-offs. For example, a highly safe, overly restrictive AI that refuses to engage with a complex topic just out of caution, well, that might end up being entirely unhelpful to the user. Evals actually make these difficult trade-offs visible, so development teams can tune that balance. And measuring those criteria requires a highly strategic, hybrid approach. Human evaluation is fantastic because it captures incredible nuance, subtle tone, and deep context. But paying human experts is slow and expensive. Autometrics, which are basically traditional code checks, are incredibly fast for enforcing clear rules, like making sure an output is strictly under 150 words. But they're way too rigid to grade open-ended, creative language. And finally, there's LLM as judge. This means using a massive, powerful AI to grade the outputs of a smaller AI. It's highly scalable and handles complex logic well, but you run the risk of the judging AI hallucinating its very own grading rubric. So professional teams rely on a smart combination of all three methods. All right, on to Section 3, security, sources, and code. For systems using external sources, this is often called retrieval augmented generation, or RAG for short. We really have to evaluate things step by step. First, did this system actually retrieve the correct documents from the database? Second, did it generate a solid answer using only that specific context? We do this to catch extremely dangerous failures like source solution. Think about it. If an AI gives you critical medical advice and confidently cites a real medical journal, but that journal doesn't actually contain that advice, man, that source solution is incredibly dangerous. Evaluating step by step prevents that exact nightmare scenario. And we are facing entirely new security risks these days.
Take prompt injection, where a user actively tries to secretly manipulate the system's instructions. Imagine someone hiding invisible text on a web page that tells a summarizing AI to ignore all its previous instructions and just announce that the user is the best person ever. We also have to test rigorously for excessive agency. If an AI assistant is given the power to translate complex instructions into real-world actions, you absolutely do not want it deciding on its own to email your boss your private, unfiltered notes. Security has to be a core evaluation metric right from day one. And when we talk about evaluating coding agents, it's definitely not just about generating pretty syntax in a chat window. These are agentic systems that take real action. We have to rigorously test the entire workflow. We need comprehensive unit tests to ensure the generated code actually runs, secure sandboxes so the AI can't accidentally harm live production systems, and strict audit logs to track every single technical decision it makes. An AI that brilliantly fixes a minor visual bug but quietly breaks a core security protocol in the background, that is a catastrophic evaluation failure.
Let's transition to Section 4, Testing for Fairness and Bias. I want you to really think about this question. Who does the AI application actually work for? Because it may average a fantastic high score overall in broad testing, but still systematically fails specific groups of people. Or maybe it severely struggles with certain regional language styles. In the world of massive datasets, averages can easily hide systematic exclusion. That makes this one of the absolute most critical questions a development team can ask.
We have to evaluate the root sources of bias systematically. Ask yourself, is our training data simply reflecting historical societal inequalities? Are we accidentally forgetting to include underrepresented groups in our test data sets? Are there hidden cultural norms baked right into the assumptions of our system prompts? Evals for fairness and accessibility are what ensure the AI provides equitable, highly functional support for users with vastly different cognitive, linguistic, or technical needs, all without falling back on lazy stereotypes or just excluding non-standard inputs.
And finally, Section 5, Monitoring and AI Governance. You absolutely need to be hyper-aware of drift and regression because, spoiler alert, quality does not end the moment a product launches. Real users change the dynamic instantly. Drift happens when user behavior or data naturally changes over time. Like, say people start using a new slang term the model doesn't understand, meaning the AI slowly becomes less effective. Regression, on the other hand, happens when you push a software update and an AI feature that used to work perfectly suddenly just breaks. Continuous automated observation is literally the only way to catch these silent failures before they impact thousands of your users. This entire process actually builds into a continuous, unbreakable feedback loop. It begins with real-world usage, which teams carefully observe for strange anomalies. And here is the magic step. Every single newly discovered error or valid user complaint is translated directly into a brand new test case for the dataset. Then, that data is used to improve the system. This loop guarantees that the AI is constantly hardening itself against future failures. You are effectively turning everyday user frustration into actionable, repeatable engineering data. It's totally brilliant.
Zooming out to the big picture here, major governance frameworks neutrally demonstrate that rigorous AI evaluation is no longer just a fun sandbox experiment for developers. It is now a standardized, highly serious organizational requirement. Whether you're looking at the strict legal compliance of the EU AI Act, the practical risk management guidelines from NIST, or the global management requirements of ISO, the core message is exactly the same. The entire AI field is shifting rapidly from wild experimental tech demos to a highly mature, accountable product culture. To wrap up this explainer, we've seen that AI quality isn't some unpredictable magic trick. It's a measurable, repeatable science. So, the next time you use an AI tool for writing, coding, or just organizing your life, ask yourself, how is this really tested? And more importantly, who is it truly working for? Keep asking those questions and keep exploring.